One of the most common questions I get asked while speaking to clients and partners across the world is how is Organica's food chain reactor system, or as you call it, the FCR, different from the SBR systems available in the market? In this video, I'm going to explain the key differences between the two technologies. The SBR is fundamentally different than the FCR in all respects. Let's start with the basic design principles. As the name signifies, SBR treats wastewater in batches, while the FCR operates in a continuous steady state mode. Depending on the number of basins in the SBR, the size of each batch may vary, but given the usual cycle time, there will usually be 3 or more batches of treated water in a day. A higher number of basins increases the number of batches and also offers more flexibility. However, 3 is usually considered a minimum for a good design. In comparison to this, the FCR operates in a continuous mode. The wastewater flows through all the unit operations, and as the water becomes progressively cleaner as it reaches the other end. The second main difference between the two systems is that while the SBR utilizes the suspended biomass model, the FCR relies entirely on biomass fixed to the natural and engineered media housed in the reactors. This difference has a big impact on the operation of the two systems, which I'll come back to later. Another point of difference is how both systems handle the peak flows. Since the SBR is a batch process, either we need an equalization tank at the start, or each of the basins has to be sized to accommodate the diurnal peak flow. In addition to this, due to the batch operation, in some cases, there is also a requirement of an equalization tank downstream of the basins to offset the peak generated by decanting only 3 or more times a day. This offset in the downstream peak is required to keep the sizing of the disinfection, filtration, or any other operation downstream of the basins to an appropriate size. In an FCR, the various unit operations are all sized to accommodate the peak flows, while the biological reactors do not need to be oversized to accommodate a peak factor up to 2.5x. Therefore, whatever comes in goes out at the same rate without any need for equalization tanks. As a result of all this, the basins in an SBR systems are usually 3 times bigger than those in an FCR. Now let's look at some operational differences. As SBR is a suspended growth system, it has similar issues that you would normally face in a conventional activated sludge treatment plant like sludge bulking and foaming. Sludge bulking actually is more prominent in SBRs since the active biomass goes for a considerable period without food during the settling and the decanting phase. Some modified versions of SBRs allow a continuous feed to the basins to offset this issue. However, in these cases, maintaining the sludge blanket during settling and decanting is even more difficult, since the rise in the water level due to continuous filling can easily cause a breakthrough. Therefore, it has to be carried out very carefully. In an FCR, since all the biomass is attached to the media, there is a predatory food chain within the reactors that keeps a certain minimum food going to all the biomass within the reactors, although there is always a continuous supply of food coming in due to the continuous operation. Due to the significantly lower suspended solids in the basins, given that it's an attached growth system, the mass transfer efficiency in an FCR is 30 to 40% higher than in any suspended growth system. Now, this reduces the size of the whole aeration system in an FCR, which makes it much smaller than an SBR, resulting in substantial savings in power consumption. Point to note that this advantage of an FCR is actually against all suspended technologies. Another main difference is the phase separation step. While the SBR relies on decanting water from the top of the basins, the FCR uses either clarifiers or disc filters as the final step for TSS removal. Decanting requires careful control for reasons explained earlier. Disk filtration is a widely used system that operates by gravity continuously and requires water to pass through a fine mesh that acts like a barrier for TSS, thus ensuring consistently low TSS in the effluent water. Due to the delicate nature of operations explained earlier, SBRs require sophisticated control systems and a highly trained operations staff to operate the plant in a stable state. Last but not the least, one of the most important differentiators of the SVR, not just compared to an SBR but any other solution, is unique look and feel and odorless operation that are a hallmark of all Organica wastewater treatment facilities.